Today's lesson starts off with a question. If we are told that two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, can we conclude that the triangles are congruent? Well, what does that mean? It means that if we are given a side length of one triangle is equal to the side length of the other. So I'll move the black one down here. And you saw that those are congruent. And what we're going to do is line these up with the bottom. This one's going to be a little bit rough today just because there's lots of maneuvering that I have to do and it's going to take a while. But let's say that I'm given this length and I want the side that comes off that makes this angle to be at 40 degrees. So I'm going to insert a line. I'm going to connect it right there and then make it come off at 40 degrees. And then I want the other line that comes off forming this angle, let's say it's at 50 degrees. So I'm going to insert set it up at 50 degrees. And what you see is a triangle made with a 50-degree angle here and a 40-degree angle here and a certain length on the bottom. Now I'm going to get rid of my protractors. And what I realized is that this doesn't have to be that long. I can shorten it and hopefully I keep it in the right line. Cool. Now if I set up the black one the same way, are we going to have the same side lengths? So basically, can I use this side and this side to form the 40-degree and 50-degree angles? So what I'm going to do is copy these and paste and then move so it's at 40 degrees and then do the same thing, copy, paste this one, set it at 50 degrees and see if they touch. At the points. And you can see that it's at 50 degrees and they touch exactly. I guess I can turn that to black. And those two work. So I have this triangle. So I'm going to just draw it instead. So side angle side postulate says that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So basically, if we are given that this side is equal to this side and this angle is equal to this angle and this angle is equal to this angle, then the other sides and the other angle will also be congruent. Next question. If we know the two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another, are the triangles congruent? Now this is where it gets a little rough because we're working with a non-included side. So I'm going to move black down here, keep blue up here, and let's say that I want to keep this at 50 degrees. So we are given this side length going like this, and then we want to make a triangle, let's say with 50 degrees in this corner, and let's say maybe 30 degrees in the lower corner. But I'm not given this side length and I'm not given this side length. All I'm given is this. So I'm going to have to work around and kind of move this around and this around so that it fits at 30 degrees and 50 degrees. You'll see what I mean in just a second. So set this at 50 degrees, and we know that we're going to have another line on the bottom. So I'll set another one up flat to make that 50-degree angle. And then I also want a 30-degree angle. So I'm going to have to set up a 30-degree. And basically I have to move these around so that they match up, which is a little bit tricky. Say, alright, I'm keeping this side length, but I can move this side length around, and I have to eyeball this to the point where I see that the 30 is going to meet the end of this. So I'm going to keep on moving it back in hopes that the 30 will continue to stay there. I think I got to keep on moving it back a little bit more. Just a little bit more. I think that's it. Yep. And then therefore I'll move that to create the triangle. I'm going to do the same thing with black. Set this up equal to 50. And then what I'm going to see is, can I use this side length, join it with the given, and this side length, join it to create the last side. Can I use those to create a 50-degree and 30-degree angle? And sure enough, we have 30 degrees right there. So I'm going to make these both black. And that's what I get. So if we're given two angles and the non-included side of a triangle, so we're saying we are given this, and then we're given this angle, and we're given the non-included side off to the side there, equal to that, equal to that, equal to that. That is the angle side. So how we can think of this is going around the triangle, we're given this angle, and the next thing we're given is an angle, and then as we go around, side. You can also call it side, angle, angle. Whichever you prefer, most people just call it angle, side. Now, a proof. We'll do this one together. We're given that AE bisects BD. So, statement, reason, AE, say, bisects BD. So what we know is that AE cuts BD in half. So right away I'm going to draw these in. So this is given, and what we can conclude is that BC is congruent to DC, and that's because of the definition of bisect. We're also given that angle B is equal to angle D. This angle and this angle are equal. What we want to prove is that triangle ABC equals triangle DBC. We aren't given anything else, but what we can see is that these are vertical angles. We'll call this angle ACB and DCE. And they are congruent because of the definition of vertical angles. Or you can say a vertical angle theorem. Once I have this, if I'm going around this triangle, I say I have an angle and then the side and the angle. So basically the side between two given angles. So triangle ABC is congruent to triangle DBC, and that is the angle side angle theorem. Last thing to go over today is the hypotenuse leg theorem. If the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, then the right triangles are congruent. Well, we know right away that these are right triangles. And the hypotenuse is the side that's across from the right angle. So if we're saying that this hypotenuse is equal to this hypotenuse, we're also given, let's say, a leg. Legs are the two sides that form the right angle. Then we know that the two triangles are congruent. So if we're given a side and another side, and then we know this angle is 90 degrees, therefore they are going to be congruent. And I'm not going to go through the proof for that one. So right here we have a right triangle, another right triangle. We're given that AB equals BD, so I'm going to draw the right way. We have statement, reason, and my computer keeps on messing up like that. Apologies. That's given. And then we also know that in these right triangles, they share this side, BC. So BC is congruent to BC, and that's given. And we also know that it's a right triangle because angle ACB equals 90, and also angle DCB equals 90, so therefore they're congruent to each other. And that's the definition of perpendicular. You can just say right angles. Therefore, if we're given that they are right triangles and we are given the hypotenuse is equal to the hypotenuse of the other and a leg is equal to the leg of the other, then we know that triangles are congruent because of the hypotenuse leg theorem. As far as the homework goes today, not too rough. Ask me questions as you're going through.